Hi, my name is Laszlo Pokorny, and I'm going to talk to you today a little bit about p-value, how to determine the p-value, and how to interpret the p-value for hypothesis testing in statistics. Now, hypothesis testing is a way for researchers to determine whether they will accept or reject the null hypothesis in favor of the alternate hypothesis. The p-value is a method of hypothesis testing that provides evidence against the null hypothesis. Let's go through a few p-value basics before we go on to an example. Okay. The first thing to note is that in hypothesis testing, the obtained p-value is compared to a selected alpha level. All right, that's the confidence level that the researcher selects before running the test and obtaining the p-value. And as the p-value decreases, evidence to support rejection of the null hypothesis grows stronger. Now let's talk about alpha level. Like I said, the alpha level is selected by the researcher, and it is common to set the alpha level around 5%. 95% confidence in their research indicates that the alpha level would be at 5%. Okay, a 5% alpha level. And if we compare, at the end when we obtain our p-value, we're going to compare the p-value to the alpha level. And if the p-value is less than or equal to the alpha level, then the null hypothesis is rejected in favor of the alternate hypothesis. And if the p-value is greater than the alpha level, then the null hypothesis is not rejected. All right, let's go right on to our example now. So in this experiment, we have 60 students who are randomly assigned to either a gamified experimental group or a traditional educational delivery in a control group, 30 students. So they're split 30-30. The course content and the final exam are the same for both groups, and the researcher wants to know and compare the mean exam scores for the two groups to determine whether there's a significant difference in outcomes. So the first thing the researcher does is create a null hypothesis in which he says the mean of group 1, that is the control group, is equal to the mean of group 2, which is the experimental group. And the way we can put that in words is that the null hypothesis is there's no significant difference between exam scores of the control and experimental groups. Now the alternate hypothesis to that would be that the mean of group 1 does not equal the mean of group 2, and that there is a significant difference between exam scores of the control and experimental groups. Now we're going to select a significance level or alpha level of 0.05, that's 5%. And so our decision rule for this experiment or for this analysis is going to be if the p-value is less than the level of significance, which is the alpha level of 0.05, then we reject the null hypothesis in favor of the alternate hypothesis. So let's go directly to our raw data in an Excel file that I have right here. Column A represents the control group exam scores, and column B represents the exam scores of the experimental group, the gamified group. Now fortunately within Excel we can do the unpaired t-test to compare the means of these two groups. And I'm going to show you how to do that. Just go to Data Analysis and select a t-test to sample, assuming unequal variances. Hit OK. And we want to select a range from the A column as variable 1 and compare it to the data in column 2. The hypothesized mean difference is 0. That's the null hypothesis, that there is no difference. We set our alpha level here at 0.05. and let's say we'll let our data be displayed right here in the D3 area in that box. Okay, so let's select OK, and there we have our results from this t-test, the unpaired t-test, comparing the means of the two groups. Let me just spread this out so we can read the data easier. And what we have is this has calculated the mean for us of variable 1, which in this case is the control, and variable 2, which is the experimental. And the n for each group is here, is 30. The hypothesized mean difference is 0. That's our null hypothesis. Degrees of freedom is 58. The t-statistic is negative 1.213311. And if we skip down here to the p-value for the two-tail, we have the p-value here of 0.22992912. So in this case, Excel has calculated the p-value for us. But let's say you didn't have this software to calculate it for you. You could simply take your degrees of freedom and your t-statistic and go to any number of tables online or p-calculators online and enter that information in there, and it will give you the p-value. Now, the question is, in hypothesis testing, is this p greater than our alpha, or less than and equal to our alpha level, which is 0.05? So, so right here, if we look at this, since the p-value, which is approximately 2.2303 from the output I just showed you, is greater than our alpha level of 0.05, we cannot reject the null hypothesis. All right, we cannot reject the null hypothesis, and therefore we would report that as the outcome of this statistical analysis. Thank you very much for your attention. I hope this was helpful to you, and have a great day.